All right. Good evening, everybody. Happy Earth Day. Thank you for joining us on this special day where we take some time to consider this big planet that we all live on and the effects we have on it and how we keep track of those effects. I'm very happy to have tonight's guest with us here tonight. I'm very happy to have our audience here tonight as well. Thank you once again for joining us for the continued virtual public programs being offered by the Museum of Flight in Seattle. We are proceeding again with an abundance of caution, coming to you live in the safety of your own home. So thank you very much for joining us tonight. My guest tonight is Ensign Kennieth Brewer. He is the Public Affairs Officer and DHC 6 pilot for the National Oceanic and Atmospheric Administration's Aircraft Operations Center. He's going to be sharing information about NOAA's various airborne missions, which includes hurricane surveillance, snow survey, and marine mammal survey. We're also going to hear about the many types of aircraft that NOAA utilizes in these missions and how these missions impact our understanding of the Earth's ocean and atmosphere. So please help me in extending a warm virtual welcome to our guest tonight, Ensign Kennieth Brewer. Ken, how are you?
Doing well. How are you?
I'm doing great. Thank you so much. Where are you joining us from tonight?
Right now, I am in my home office in Lakeland, Florida. It is nighttime here. I can see the sun out behind you in your window.
Yeah, we still have about another hour or two of daylight here.
Yep.
You were telling me before we got started that you just came down from a flight here earlier.
I did. I probably landed about an hour ago out on a training mission. And I raced home, and I'm excited to be here. We're going to have a great time tonight.
Awesome. Well, we appreciate it. At this point, Ken, I'll bring your presentation up on the screen, and I will turn it over to you, sir.
Sounds good. Thank you very much. All right. I'm going to go ahead and transition my slides here. Good evening, everyone. As you know, my name is Kenneth. It's Kennieth. My call sign is Blue. That's BLUE, or just Blue. Either one works. If you have a question, please get with Kale, and he will take care of them. We're going to hold those till the end, but let's get to it. All right, I'm very excited. As you can see, these are some of our aircraft. We are based in Lakeland, Florida. So tonight we're going to talk about a little bit of our aircraft, our mission set, the different types of aircraft. You can ask questions, of course, about the aircraft or the facility or my personal journey. Any of those, nothing's off limits. So that being said, we have our outline. So we have NOAA as Big NOAA, and then we have NOAA Corps. So a lot of people don't know that NOAA Corps is actually the 7th Uniform Service. I guess you could say it's the 8th Uniform Service now that the Space Force has actually combined their forces. So you have the Army, Navy, Marine Corps, Air Force, Coast Guard, and the Space Force, and us. So we are one of the uniformed services of the United States. With that, there's also the civilian side. We don't have an enlisted corps, so all of the enlisted personnel jobs, such as maintainers or scientists, are actually done by civilians. So that's one thing that's very unique. The Aircraft Operations Center is under the umbrella of OMAO, or the Office of Marine and Aviation Operations. And above that is Big NOAA, so the National Oceanic and Atmospheric Administration. We also divide our AOC into multiple different aircraft types. So we're going to talk about some of our light aircraft and some of our heavy aircraft, and especially some of our hurricane hunting aircraft. And with that, I'm going to go ahead with our first video. I'll let you take controls here. All right, very cool. And I hope that had sound so everybody could hear it. So our key missions are science, service, and stewardship. How do we be good stewards of the environment while also providing the science, information, and the services that our nation requires? With that, we talked about it. We have the NOAA Commissioned Officer Corps. So we date our lineage back to the Coast and Geodetic Survey that was put in place in 1807. With that, we are the smallest uniformed service, but we're still older than the Air Force for all you Zoomies out there. We are the smallest uniformed service of only about 320 officers. We got approval last year to actually bump those officer numbers up to about 500. So we're doing a huge hiring effort for NOAA Corps officers. With that, we require those science backgrounds, of course. If you want to know more about that, we will definitely have links further on. With that, we have about 15 ships, and we have now 10 aircraft. We also have a G550 that is being built. It will eventually replace our G4, and that is being built up in Savannah at Gulfstream currently. With our ships, we do mapping of the ocean floor, fisheries, and oceanographic research, as well as our atomic missions or the atmospheric research missions. As you can see there, we have the Ron Brown with one of our P3s flying over the ship down in Barbados. Now, the NOAA Aircraft Operations Center has pilots and navigators. They're on the NOAA Corps side. And the civilians are our meteorologists, our mechanics, our maintainers, our engineers, our support staff, our admin staff. Those are all done by civilian personnel. So we have a pretty good mix. We have about 160 people that work at NOAA AOC, and we have about 45 to 50 officers, depending on what the rotations are looking like. This is our home down in Lakeland, Florida. You can always identify us off the corner of Echo 1. We are the big blue NOAA aardvark, as you can see. And we have about a 250,000 square foot facility. We have a hangar for heavy aircraft and light aircraft, a full maintenance hangar, a full facility bay, and we house about 120 people that work there on a day-to-day basis, meteorologists and other researchers that are based at the NOAA Aircraft Operations Center. So what kind of aircraft do we fly? Well, you can see we have a variety of different aircraft, and we're going to break those down into each one of our airframes here pretty soon. But you can see on the left half of your screen, that is our light aircraft, and then our heavy aircraft are going to be the two that you see over there on the right side of the screen. As we roll on through, we're going to talk about the DHC Twin Otter. That is the best airplane we have in the fleet, and it's my favorite aircraft because it's my primary aircraft. So with that aircraft, we do low-level marine surveys, air chemistry, coastal mapping, and snow surveys. So with marine mammals, we're going out and we're actually looking for right whales. We're looking for sea life of any kind. We also do seals and sea lions out in Alaska. So we're kind of looking at any marine life that is out there. We usually fly those missions somewhere between 500 feet and 1,000 feet. So somewhere in between there. With the air chemistry, whenever the state of California has their big forest fires, we will actually go out and fly through the smoke in order to collect that air data and to read all of the different chemicals and the different amounts of toxins that might be in the air in order to help predictions and where that smoke is going to be carried. Is it going to be toxic, and what is part of that chemistry itself? We also do coastal mapping. It's important to know the coastal boundaries of the United States because our international boundary starts, but as the coastline changes, the international boundary also changes. So we always need to be aware of that. With that, we also do snow survey, which is also my favorite mission. We have 4 of those Twin Otters as well, and they are beautiful birds. So you can see just here that one of our scientists, or marine biologists rather, Allison, is actually looking out one of our bubble windows, and you can see a pod of right whales down there. Now the right whales, we're trying to regrow the population. They are an endangered species. Why is it important? Because we want to know what is in our environmental waters and how to protect those animals. So we have a huge effort that we actually do with the Canadians as well in order to get the populations of the right whales back up. You can see just some of those absolutely beautiful animals. Now, what do we use this airplane for? A lot of times we are flying surveys in a zigzag formation that will allow us to track the animals down. And then once we get there, the marine biologists in the back actually have books that they can identify those whales, They don't always use them, mainly because they know them, like they're their own dogs or something at home. They'll be like, oh, that's Fluffy, and oh, that's Steven. They call them out by name. It's very, very interesting. We can also see if there's any wells that are entangled, as you can see here, and we can actually circle that well and tell the small boats where to go in order to cut the well free and to save its life. So that is our NOAA Twin Otter, and that is actually our patch. So you'll see our patches as we float through these aircraft. Now, again, this is my favorite survey, and that's snow survey. We do that with the Turbo Commander. Now, the Turbo Commander is a very important aircraft because it is actually on its sundowning tour. So this is its last fiscal year of operation before the aircraft actually retires. We have replaced it with a King Air. It is a 350 CER, and we are going to be doing snow survey with that now, which is going to be very interesting. So we've actually been working in northern Alaska and northern Minnesota and Michigan in order to compare the two data points in order to get that level data to continue utilizing the King Air. So we do those missions at 500 feet, and it is terrain following. So if you go down in a valley, power comes out, and you go down, and you stay at 500 feet the entire time. Now, why is that important, and what are we doing? So we are measuring what is called snow water equivalent, or SWE. So what we want to know is how saturated the snow is. As you'll know, out west in Washington, you have really light, fluffy snow, and that's pretty good for making like a snow angel. And then you have really hard, wet snow, and that's good for like hitting somebody with a snowball. Not condoning any kind of snowball violence, but if you're in a snowball fight, you know which snow you're needing to grab. So that is because of the differences in saturation of the snow. Why do we want to know that? Because we want to know the flooding probabilities later on in the seasons, whenever the thaw comes. So if we know the saturation of the snow, or the SWE, we can better predict the flooding that might happen in those places like Springfield, Missouri, for instance, that some of those fields that are outside of the city will get flooded a lot, or some of the neighborhoods. So we can help those flood predictions as we go through. We have NOAA 45. That is our only Twin Commander, and it is going on its sundown tour. Now, these snow lines are very interesting. We fly them in late fall, and then we fly them again in the winter. And we're not going to play this video, but we fly the same lines in order to predict and get a good baseline in the fall, and then get a good baseline in the winter, and then we know better where those snowfalls actually are. Pardon me. Now, the Beechcraft King Air, we do a ton of coastal mapping. As we said, we just brought another one online that's going to be doing snow survey as well. But we have cameras in the back. We also have LiDAR that can be mounted back there in the back of the aircraft, and we can do imagery. So with that, after a hurricane goes through, we're talking about weather as well, after the hurricane goes through, the coastline is completely different. We need to go back in and remap that. For those of you that are old enough during 9/11, the first responders really didn't know what was going on. We flew the mission with our LiDAR system, and we're able to map ground zero in order to help first responders allocate resources. We do the same exact things with disaster relief, such as tornadoes in the Midwest as well. We can go in, map, and first responders like FEMA, fire departments, police departments can allocate resources to those areas that are most in need. With that, we also have our second aircraft coming online that's going to be doing snow survey with that aircraft now. Now, this is Hurricane Michael. If I might be able to play it off of this, there's no sound with this, but you can see this is before the actual storm went through, and then you can see the coastline after the storm actually went through, and just the devastation that one of these storms actually has. So to know that you can allocate resources to a certain area by providing immediate coastal mapping to the people who are the head of these resources is extremely valuable. And that is our NOAA King Air. Moving along. So why do we fly hurricanes? We've talked about our light aircraft mission. Now we're going into our heavy aircraft mission. So our 2 P3s and our 1 G4, our Gulfstream G4. We fly them to better help and predict what the storm is possibly going to do. About 50 years ago, we could tell you within roughly 200 to 300 miles what the storm might do or where it might hit. Today, we can tell you within 2 miles of where that storm is going to make landfall. That helps with evacuations, with helping the elderly, with help with those less fortunate that might be living on the streets. That helps with all of those different things in order to allocate resources and help the people and the communities that are going to be affected by these severe storms. With that, we are going to talk about our Gulfstream G4, commonly known as Gonzo. So the mission of the Gulfstream G4 is actually to fly high above and around the storm. Kind of like if you were a pilot and you need to know how to taxi. You don't want to know what's going on in your taxiway. You want to know what's going on all the other taxiways in order for you to get to the runway safely. Same thing we're doing with the Gulfstream G4. We're flying above the storm in order to measure that upper atmospheric data, that high pressure system that's setting on the lower pressure systems. And we also want to know what's going on around inside the Gulf of Mexico or off the coast of the Atlantic or down in the Caribbean. Because knowing where those storms are tracking is going to be mostly towards warm water, towards warm air, and towards good hurricane conditions. So if we know the data that's around the storm, we can help to predict what those storms are likely going to do. The dropsongs that we actually use are extremely important in collecting this data. They measure temperature, barometric pressure, wind velocities. All of that information is sent through an internal computer that is completely housed inside of the SON itself, and it's about the size of a Pringles can. And then that information is radioed back to our aircraft, and these are dropped both out of the P3 and the G4. Now, why is it important? Because it gives us precise data. As you can see, that right picture there of Hurricane Katrina, the red line was the predicted path of the storm. After flying it with our aircraft and utilizing our dropsongs, we were able to predict that the storm was in fact going to turn and hit New Orleans dead on. With that, we're going into our money makers. So these are our WP3D Orion, specifically made for NOAA way back in the 1970s. And yes, we are still flying them. And yes, we have re-winged them recently. So we are good with these aircraft until about 2035 is what we're predicting. So these are our hurricane aircraft. They gather storm information from inside the actual storm. We have 2 of them, Kermit and Miss Piggy. We'll get to the names here in just a moment. But as you can see, we have that huge probe that sits off the front. We have a forward-looking radar. We have our MMR, which is that big black M&M that you see on the bottom of the aircraft. And then you can see just a little bit that TDR, or Tell-Doppler radar, that actually gets a vertical cut of the actual air or the storm as we fly through it. We fly at about 8,000 to 10,000 feet, and then we're dropping dropsongs throughout that entire time. With that, I know everyone's asking, why do they call them such funny names? So I'm going to tell you the story. The Pig is the P3. So we had a crew chief that was not always the cleanest. It was a pretty dirty airplane back in the 80s, and they called it the Pig. Well, that crew chief retired. Another crew chief came in. It was the 80s. The Muppets were huge. And he said, what is the cleanest pig I know? And he said, you know what? Miss Piggy. And so they called it Miss Piggy. They drew up a funny little sketch and they sent it to Jim Henson because NOAA is a government organization. We don't like to copyright most people. And so we sent it off and they said, oh, no. You cannot use that. It is too crude of a drawing. And so they sent us back the artwork that you see now, which is still on our aircraft today. And so thank you to the Disney Corporation and the Jim Henson Corporation for actually providing that beautiful nose art for us. And we can't wait to get that G550 on board and see what you are going to name that one. Well, you can't have Miss Piggy without also having Kermit, her boyfriend. And so we have Kermit and Miss Piggy, which is absolutely one of the most fun things that we have. And then we also have Gonzo, the G4, and that's because if you ever look at a picture of our G4, it has a very elongated nose to fit that larger radar dome that we actually need. And so it has a funny long nose, just like Gonzo. And so that's Gonzo, the flying G4. With that, we are a flying laboratory. So like we said, we have huge probes that stick off of every orifice that we can put something on these airplanes. On the picture on the left, you can see that huge long tail. Now, those of you that are out west and you were like, oh, I remember P3s from the Navy, or people like me who are over near Jacksonville, Florida and say, oh, I remember P3s from the Navy. You remember that they had a big submarine boom that was back there. We just made that boom much larger, fit a vertical Doppler radar in there, and now we call it the TDR, the Tell Doppler Radar. As you can look on the picture on the right, we actually have that forward-looking radar that is under the nose of the aircraft, and then below on the belly, where the Bombay used to be in most P3s, we actually have a MMR, or multimodal radar, that we can actually turn. It has two radars that kind of look like that back to back, and we're able to turn it to look where we want to. And here is our hurricane penetrations and all of the all of the countries that we have operated out of. And this is just one of our aircraft. The other one has their own set of battle scars as well. And you can see just how many cyclones, hurricanes, and typhoons that we've been through. You can see the hurricanes that are actually backwards are the ones that we've done down in Australia and down in the South Pacific. So that's pretty interesting. Under that, you can actually see a couple of those holes, and that's where we preload dropsongs. They're about 4 foot tall, not that big around, about 8 inches. And we're able to preload those and drop them out as well. With that, we have a wonderful presentation of Hurricane Irma from 2017. You can just see how wretched it is to fly in one of those storms. Kale, I will pass it over to you, sir.
So completed to a Category 5. As you can see, the image hasn't really changed much. It's a little old, but it hasn't changed much over the last several hours. It's a strong storm. It's intensified slightly since NOAA 4.2 left.
You can see just how intense these storms are. The gentleman in the middle is actually the flight engineer, and what he is doing is moving the throttles up and down. There's 2 sets of throttles on either side. We're trying to maintain 210 knots as we go through. The gentleman in the back standing up is actually buckled into one of our standing seats, and he is an FE that's about to come on, so he's trying to see what is going on. And this is inside of Hurricane Irma when it was a Category 5. You can see that beautiful stadium effect, very well developed low pressure system. Here's another shot of that gorgeous stadium effect. And I know someone's going to ask, yes, it is as calm as you could imagine within that storm. It goes from being absolutely terrifying to very, very calm in just a couple of minutes, which is insane. And you can see that they're turning left and right, and that is because the flight director, who's actually sitting behind the flight deck, is telling them where to avoid thunderstorms that are developing within the actual storm itself. So we want to get in between them so we don't go straight into them. All right, and that is what the inside of a hurricane looks like. It is very interesting to say the least. Very cool. We can move on if you're ready. Thank you, sir. All right, I'll pull my presentation back up. All right, and we continue on. So now you have flown with me through the inside of a hurricane. The gentleman on the left side of the aircraft is actually the pilot flying. Their one job is to maintain wings level and the nose on a pitch attitude that will not climb or descend too much. The gentleman in the middle is actually the FE. He's just throwing the throttles forward and aft, trying to maintain that 210, 220 knots. And the gentleman over on the far right with the ball cap on, he is actually the aircraft commander. So he is communicating with the flight director that sits right on the backside of the actual cockpit itself, in his own flight station or her own flight station for these flights. And they are communicating where they want the pilots to actually turn. The gentleman standing up in the standing seat is actually the FE that's about to come on within the next few passes. And so he's up in the cockpit trying to evaluate what is going on up there. So there's a beautiful stadium effect that I pointed out whenever we were actually watching the video. And it does. It looks absolutely like a big stadium. For me, it reminds me of the Bucs Stadium. There's nobody there, but everything's going on. I guess there's going to be more people now that we've won a Super Bowl. But you can see that beautiful curvature, and that's just that center of that low pressure system. So what we're trying to do inside that eye is find that zero wind point. Where is the exact center of that storm? Because that's whenever we can really start to replicate our models to show what's going on. Now, we talked about the difference in pattern. This is actually our flight path. So on the left side of the screen, we have the G4. So you can see it left Lakeland. It went out, it flew all the way into the Atlantic. It came back around the south side of the storm, went out into the Gulf of Mexico, and then back. In an average flight, they could cover 4,000 miles if they wanted to. The G4 is going at about Mach 0.8. So moving along pretty well. They can get a lot further distance than the P3. With that, you can see the P3's path. Pardon me. The P3 goes out and then does what's called a star formation. So they go down, out, up, back in, up, back in, up, back in, up. And they make just this big star going back and forth through the storm, dropping dropsongs the entire time, as well as the G4 that's dropping dropsongs above and around the storm. So we have now covered our beautiful Gonzo, the G4, the Flying Gonzo, and the beautiful Miss Piggy and Kermit, the P3s. Now, there is another hurricane hunter out there, and they are from the Air Force. You can always tell them because their engines are upside down for some reason on their plane. I don't know why, but that's how they fly. It's the Air Force, you know, not dishing on the Air Force. We love you guys. So the 53rd is out of Biloxi, Mississippi, and they have their own hurricane hunters as well. And then we have our own hurricane hunters. We team up all the time to do different beneficial tours and our mission sets. We also meet at least twice a year in order to make sure that we are ready for hurricane season or for anything else that's out there. They are great team members of ours, and we absolutely love working with them. We do more than hurricanes as well. We are a year-round operation. I know that whenever you hear the term hurricane hunter, you're like, they only go out in the summer and it's only hurricanes. That is not true. We also do tornado supercells. We do North Atlantic storm. We do coastal mapping. We are out flying the G4s and the P3 and atmospheric research out in the Pacific during the winter. We also have the atomic missions. And atomic, we study the little puffy clouds that are in the Caribbean. How do they form? We don't know. That's why we're out there trying to figure out what is going on. So we'll fly in Ireland and Barbados, and we'll measure those atmospheric rivers as well, which are big lines of moisture. A lot of people are familiar with the term Pineapple Express that is out in the Pacific. That is a huge line of moisture that goes, it has as much water in it right now as the Mississippi will flow in a single year. So it is a ton of moisture out there over the Pacific, and we want to study it because that helps with our weather predictions throughout the year. There's a fun story of the tornadoes and supercells. So a supercell was coming through the Midwest. We have our P3 flying right in front of it, and the flight director is in the back, Ashley Lundry, and she says, "Hey guys, I think we have a tornado that might touch down." And she feels the airplane turn, and she hears the pilots up in the flight deck, and they said, "Yeah, we see it. That's why we're turning." So they turned away and were able to get a very good research, but a little too close for comfort, as it were. Then we also do atmospheric research with the G4, and we also do what's called GravD, where we measure the Earth's gravity. And that's very important to understand where the gravitational forces are. As most of you know, because you're very smart viewers, the Earth changes ever so slightly. And so we have to tell NASA what the gravitational pull is going to be. Those guys don't know. Just kidding. All right, so we have our beautiful Get Involved page here. How do you get involved? These links will be up. This video will be posted. Look for these links. If you are interested in becoming a NOAA Corps officer, a pilot, a mariner, most of our officers are actually mariners. They're not pilots. And so if you want a life at sea, if you love marine research, atmospheric research, you want to map the oceans, you want to be the next Jacques Cousteau, more on you. Get out there and get involved. There's volunteer opportunities, and there's also internship and scholarship opportunities. Look them up. It is awesome. We love our job here. You can see a beautiful picture of the TDR being mounted on one of our P3s as well, which is super cool. With that, I will open it up for questions.
All right. Thank you for that presentation, Kenneth. That was fantastic. That is some interesting flying y'all do.
Absolutely.
As we wait to see if our audience has any questions, I have one for you if I can put you on the spot here.
Yes, sir.
How did you come to find yourself flying for NOAA? What was your education path and career path that took you to this point?
Yes, sir. That is it. Absolutely. That's a great question. So I studied aeronautics at Embry-Riddle Aeronautical University. If any of those pilots are out there, don't hold it against me. But that's where I went to school. After that, I started my master's. I was doing environmental research. I thought I wanted to do geophysics or something in that realm. And so I was heavy in the sciences. I absolutely loved it. I've always loved a service lifestyle. I grew up in a military family. So I wanted to give back. It's not just about me, it's what I can do for our country as well. In the great words of President Kennedy, you need to give back. And I wanted to give back. I wanted to serve. And this blended my love for the sciences and for the atmosphere and for weather. And it blended my love and passion for aviation. And that's how I started getting involved. Now, like I said, most of our officers are actually mariners. So as you get selected, you go to BOTC, which is the Basic Officer Training Course in New London, Connecticut at the Coast Guard Academy. We work right alongside Coast Guard OCS. So if you ever watch videos of Coast Guard OCS and there's somebody that says NOAA Corps on their sweats, that's one of our guys. With that, you graduate and commission as an ensign in the NOAA Corps itself. And then during your time in BOTC, you take your AFOQT and your TBAS in order to apply for aviation. If you get selected immediately out of BOTC, like I was very, very lucky, then you go straight to flight training. And if you are on ships, you will actually go out to whatever ship you are on, which is super cool. Most of our officers, or excuse me, most of our pilots actually spend about a year or two out at sea as well before they come to aviation. So it's very unique. That's kind of my path, and hopefully some of your paths whenever you apply to the NOAA Corps and become pilots with us. Let's see what else we have.
You mentioned that the P3 was going to be on that mission through 2035, I believe, is what you
That is
said.
correct.
Is
Yes.
there? Do you have any idea of what will replace it after that?
We are looking. We are not quite sure what we want yet. We used to have C-130s way back in the day. We may go back to C-130s. The big problem we are having is finding an aircraft that sits high enough. As you can see in this photo in particular, we have that huge MMR, that big black M&M that sits on the bottom. That's very thick. And we need an airplane that can fit that under. We've tried looking for them. We've also tried with flat radars, mounting flat radars on the sides of aircraft as well, to see if we can get the same type of Doppler effect. So it's just going to be some research, but I would say we have a few years to figure it out, but that's up to you. Somebody design us an aircraft, please.
It's a good task for a future aerospace engineer out there.
Absolutely. One of you is out there.
We have a question from Barry in the audience. He wants to know, does NOAA fly through all hurricanes?
That is a very good question, Barry. So we are tasked directly by the Hurricane Center that's down in Miami, and they will actually tell us what storms they want us to fly. Some storms they want us to fly from the time they get off the coast of Africa all the way until they make landfall in the United States or the Caribbean or Central and South America. And others, they prioritize. So sometimes they want the G4 to go immediately out to Hawaii and go fly a storm out there, and the P3 to go and fly a storm in the Atlantic, and the other P3 to support the Atlantic missions. So it's really what the National Hurricane Center is desiring and tasking us for in that season. It's a very good question.
Kind of along those lines, can you go over briefly how hurricanes form, and in the spirit of it being Earth Day today, what it means from that perspective as well?
That is a very good question as well. So the Earth, and this goes back to my days as a young man visiting my aunts in Queens. The Earth is like a pot of spaghetti, you know, and if we just put the spaghetti pot right on the heater and we put the heat on, it's going to burn the bottom, and the cold's going to be, the top's going to be cold. And nothing in the middle is really going to be lukewarm or something, you know, it's not going to be a good churning spaghetti. So what the Earth does, and this is so unique, and it's unlike any of the other planets, what that does is that energy that is around the Earth, that heat, that radiation, that humidity, that moisture, it gets churned in the atmosphere, and that helps to regulate all of our heat, all of our cooling, and all of our seasonal atmospheres that we have on Earth. So if you think about a wooden spoon churning that big pot of spaghetti, you know, it's the same thing that hurricane is doing. So it's forming off of these big heat patterns that are coming off of the coast of Africa, off the coast of the Saharas. They're mixing with all of those different molecules and particles that are in the atmosphere. And then they're getting that huge moisture, and they're turning into these solid low pressure systems, churning all of that energy and spreading it throughout the entire Earth. So it's very, very unique. And it's really, really cool.
And how does this hurricane season, how is it shaping up so far? I know when we were scheduling this talk, there was a little bit of concern that perhaps you might get called away at the last minute.
Absolutely, yeah. I am very happy I am here. We are expecting for it to be probably a busy season. If we are seeing, looking at last year, of course, was a record hurricane season. It was the biggest hurricane season with the most recorded storms in recorded history. So we have a pretty good timeline of researching these storms over the last so many years. And this was the busiest. So we may see another pretty busy season. We also know that we've had a pretty warm climate this past year and the year before. And we're seeing a lot of droughts. We're seeing a lot of snow droughts. So it has the possibility to be a pretty active season. So we're excited. We're already battening down the hatches down here in Lakeland, getting all of our pilots, crews, and airplanes ready for a good season. Yeah.
All right. Oh, and question from our audience here. Are your airplanes used in tracking or detecting any of the wildfires that pop up out west in the U.S.?
That is also a very good question. Thank you for asking. So we do not track or do any fire suppression with our aircraft. However, we have been known to do what's called Fire X, which is where we put these humongous computers in the back of our aircraft, our Twin Otter mainly, and we will fly through the smoke in order to collect the atmospheric data or the molecule data or the breathability studies or things like that within the actual fires itself. But we don't track them now. That's a different department.
When you talk about this data that the airplanes collect, is that data looked at by NOAA scientists specifically, or is it distributed out to a wider network?
Very good question. So it is a little bit of both. A lot of times it is NOAA scientists that will actually develop the models. They're doing a study, they're doing a research package of some kind of developmental research they're doing. And other times it is guest meteorologists or guest researchers, including marine biologists. I know that the last hurricane flight I was on was Hurricane Dorian. I believe that was 2 years ago. And we actually had 3 guest meteorologists on board at the time that were from some of the different weather centers throughout the United States. So it's not always NOAA personnel, no. We like to work with other departments of the United States government, and we love to work with other meteorologists as well.
Excellent. All right. Well, I'm not seeing any other questions come in from our audience here. I kind of exhausted my supply for you there, Kenneth.
No worries.
I want to say a big thank you for joining us and taking some time out of your what I'm sure is a busy flight schedule to talk to our audience here tonight. Oh, here we go. Dave asks, can you elaborate on how the data from the Dropsongs is gathered and retrieved, and is the device expendable?
That's a very good question, Dave. You're a clever guy. So the Dropsongs actually fall, of course, they're like a weather balloon in reverse, and they act a lot like a weather balloon. If we drop them inside of the storm, they are destroyed. By the time they reach the actual sea level, they're usually crushed by the waves, and we're never going to see them again. With that, we can also still utilize them to the fullest of our potential, because they send back the radio data. They are expendable. We do not retrieve them. They are destroyed. They sink to the bottom of the ocean and they degrade. Most of the ones now are extremely biodegradable compared to the ones they used to use like back in the 60s, when you could basically throw a big piece of steel out in the ocean and nobody would care. We've changed, especially with NOAA as a whole. We are very environmentally conscious, so we try to get stuff that is more biodegradable over time. With that, those models, that information is sent directly back to Station 5, which is actually where the Dropsongs are dropped out of. And that flight crew member will collect that data and then verify it. So the information kind of comes on like a running board, and not only numbered information, but also on a graph. And so they compare that data to what they know they should be seeing. And if it matches up, if it does make sense, then that information will be transmitted back to the Hurricane Center via satellite link, as well as our TDR, our Doppler radar information. And so those two are the immediate information collection agents that we use in order to make those models back at the National Hurricane Center. With that, if they do see an anomaly or if a Dropsong goes blank, we automatically have another one ready to be put out of the aircraft as well. Very good question, Dave.
And what specific data are those pulling? I imagine air pressure, wind speed, that type of thing.
Correct. So they are mainly looking at temperatures, wind velocities, and pressures. Pressure is a big one, especially within the eye of the storm itself. We could see as low a pressure as 850 millibars, which is pretty low, especially for a low pressure system. That's quite uncommon. With those bigger storms, you'll see that. So that data that they collect using those Dropsongs is extremely important. And yeah, we're able to send that back and start to develop those models. With that, of course, we talked about the G4. So what is going on in the big area as well, the entire Gulf of Mexico, we'll say, for our learning environment here. we want to know what's kind of going on in the Gulf of Mexico. You know, is the area of South America a little bit colder than the waters up near Mexico and Central America? So if that's so, then it might steer a certain way. So it's not just about collecting the data within the storm itself, but also what's going on around it. And that really helps us pinpoint and accurately collaborate those models into that tight 2-mile cone.
That's super interesting.
Absolutely.
Here's a good question from somebody who was paying close attention when I introed you at the top. Tim asks, as a public affairs officer, what is the best days and what is the worst days you have?
And this is not a lie, Tim, I have never had a bad day at work. I love my job. You know what? I'll take that back. I have had a bad day because I wish I was there in Washington with y'all at the beautiful museum that y'all have and able to interact with y'all outside of this medium. I absolutely love what we do. I love to share the information. I would say my best day is whenever I wake up and I get to go out to the hangar and I'm in the middle of Alaska, we'll say in Dead Horse, where there's nobody out there, and I can have my cup of coffee and look out and know that today we're going to do research that could potentially change the concept of what we know as the environment or the Earth as a whole. And that is what really kind of drives me. And as a public affairs officer, telling that story and sharing that, a lot like the people who work at the museums, sharing that knowledge, sharing that story is something that I absolutely love. I know Kale and I were actually talking right before we jumped on about one of the aircraft they have, the B-47, sharing the story of old NOAA tradition, old NOAA airplanes, especially being an airplane nerd like me, and saying, you know, we used to have one of those. We did a certain such and such mission with it. And informing people about that is really what I absolutely love. But yeah, I have never had a bad day at work. I absolutely love what I do. That's why currently it's almost 10 o'clock on the East Coast and I'm still talking with y'all, and I've probably been up since 6 because I love what we do here at NOAA. It's so much fun.
They have you flying tomorrow, Ken?
No, thank God I am off for the rest of the weekend. I leave out Monday. I'll be heading up to Minneapolis. If anyone's up in Minneapolis, we'll be at Flying Cloud. Stop by and take some pictures of the airplane and send them to our NOAA Instagram or Facebook, and we'll post them up there for you. But I'm excited to get back on the road some more. It's going to be a great season.
In fairly normal times when there isn't a pandemic, does NOAA allow the public to tour their aircraft at all? Do you ever make static display appearances?
Yes, we absolutely do. There is a process for that. As the public affairs officer, we have we like to do groups, of course. We like to do different organizations that are in aviation or weather or school groups, especially youth and STEM education. If you have a youth and STEM group, I want you to come to NOAA. I want to show you our aircraft, because that is how we bite young people, and that is how we get them involved with STEM education, with being interested in math. I was never interested in math until I took something in weather. And then I was like, oh, so this math thing actually is worth something, you know? That's where you get involved. And I love young youth groups. We love giving tours at the hangar. We usually try to do them a few times a month. Right now, of course, everything's weird, but whenever we get back to normal and we are able to, we will start tours back up. And I encourage people to not only look for tours, but to also get involved with NOAA's field offices. Y'all are very close to Oregon. There's a field office. In Washington, there's a field office. There's so much going in and around NOAA. Get a tour, go ask, get involved, volunteer, go and see what your marine biologist in your own backyard are doing and your meteorologist in your own backyard are doing. But yeah, we totally give tours.
Well, fantastic. Well, we do hope to see you in Seattle someday in person with your aircraft. So we're looking forward to that in the future. Once again, Ken, I want to say a big thank you for joining us tonight and taking the time to share the story of NOAA with our audience. I want to say a big thanks to our audience for tuning in tonight and for your questions for our speaker. And then, Ken, do you have any final thoughts you'd like to leave us with before we terminate for the evening?
I would say just make sure you follow us on Facebook, Instagram, and Twitter, and also get involved with NOAA and get your youth involved with NOAA as well. And thank you so much for inviting me. It has been an absolute pleasure to present here tonight.
Well, thank you so much for being with us, Ken. And once again, everybody, thank you so much. We'll see you again at our next public program. And for now, take care and have a good weekend.